let's do what I mentioned, which is we have everything in lists. So we're going to load everything into our list into a data frame. So let's call our data frame is trade book. You could call it whatever you want, of course. So of course we're calling it pandas, and we're going to load this into a data frame. As I said, sorry, there's a typo there. And so we're going to load our trade list. We're going to specify the columns for our data frame. We're going by name, so it's the date, time, the date whenever the trade was open, and the open price. Doesn't matter, it's just something that is just a name that makes sense to you. So the stop price, let's not use spaces, just that. And so the stop price and the target price, followed by the target price is the date that we close our trade. So let's call it date close. And then we'll have our close price, of course, which will be either the stop price or the target price, and then one last column just to hold our P&L, which is in percentage, so the percentage of P&L, for example. Okay. So we've done that. We're loading everything into our trade book, and we have a typo here. Yes, because it's one too many parentheses. Pardon. There you go. So we've done that, and we need to set an index for our data frame. So we're going to say that our trade book index is our date, our open date, which we called date open. And there you go. So we have set the index for our trade book. So there's a typo there, and that's why that doesn't exist. Let's just run this and see if it compiles out any problems. Again, no problems. So what we can do now is we can check what's the information there. So the trade, we could print entire book, but it would be too big. So let's get the information on that on our data frame. So no. Sorry, just make sure that I have. Yeah, seems right. So why is it not loading? So let's remove the data info there. It's not because, sorry, my bad. I know why. So let's just hash out that anyway, because I actually I haven't called a function. So I've put everything under the sim function, and I haven't actually called it. So let's just call that function. Okay. So I have a typo here. I misspelled the word columns. Third time lucky. There you go. Let's see if it compiles now without any issues. And there we go. We can see our trade book. We can see there were 249 trades. And of course, there's the first column, which is the date that the trade was open, is our index, so it's not listed there. Okay, so it's compiling. We see that it's done the code. So now we should perhaps get some basic information about our back testing, just to get an idea of what we've got here. So so what? So let's calculate some parameters for it. So let's calculate. Obviously, very interesting is what's the sum of our P&L. So if we print that into the screen, let's just call sum P&L, and we can obviously using the data frame functions. It's very easy to do that. We can just call it the trade book sum function. So the column we're interested to sum is the percent P&L column, which I believe that's what we called. Yes, percent P&L. And then we just call the sum function. Okay, so let's see, let's compile this. Error. Because percentage P, because it's capital L. Let's put a capital L. Okay, it should compile now, and there you go. So that's the calculation, 101% out of 249 trades. So that's a good sign. So the other thing we should count is to have an idea of how many of these were actually up. So let's print that into the screen. So let's just call it P&L greater than 0. Sorry, I forgot to put the commas there. Right, and again, we're going to use pandas built trade functions, pardon. So trade book. Sorry for the noise outside, I should have closed the window. So the trade book, and again, the column we're interested is the percentage P&L. Right, and then we want only the greater than 0, and we're going to sum this and see how many of the values. Okay. Right. Let's see if this compiles. Float has no attributes, so what did I mistype there? So yes, because it's this, and then we pass. That's right. Okay, so we've seen that the total number of trades that were positive was 147 trades out of 249. So we can, of course, calculate a percentage for that. So let's just call the percent of P&L that were greater than 0, so they were profitable. Let's calculate that. So obviously it's that value that we just calculated. Let's copy that, multiplied by 100, divided by the total number of trades, which will be the length of the trade book, which we know is 249. Right, there you go. And let's run this. And there we go. We can see that 59% of our trades were profitable. We could actually round this as well, just for sake of convenience and presentation. So just round this to 2 decimal. There you because I've printed the entire instead of pardon there. There you go, 59.04%. Right, so let's now calculate the average win. So if we call it average win, which will be, so we're picking our data frame, and the function we're going to use here is group by, because we only want to get the average win, so we want the sum of the P&Ls for only the values that are greater than 0. So I'm going to group by and then of course we only want the P&L column, so the percentage P&L, and of course we only want the P&Ls that are greater than 0, as I said. Now I'll show you something. So if we're just to sum this, yeah, if we're just to sum this, let's see if I have any errors there. Yeah, we do. Yeah, because we didn't put the there. There you go. So if we were to sum this, it actually returns both the so there's all the columns, so all the sums, it summed all the columns, and this is the one we're interested. So that's the sum for all the negative values, and this is, because you can see false when it's not greater than 0, so it will be smaller or equal than 0, and true when they're greater than 0. But we're only interested in this column and in this value when it's true. So what do we need to do? We need to add that's the column that we're interested in. So if we put the percentage P&L, and then because that will give us just that column, but will give us the false and true, and we only want the second one. So we're going to say it's the second one we're interested. So let's compile this. Okay, syntax. It is because I've put a dot there and there's no dot. What is there now? Yeah, that's the missing dot. And there you go. So that's the sum of our of all our wins. So it's still not the average. So that's actually, I should just skipped one step. So that's the sum of all the P&Ls greater than 0, or the percentage of the P&Ls greater than 0. So now we can do the average. So let's print. We're doing step by step instead of just calculating the average in a single step. So let's put that the average of the P&L greater than 0. Which is, of course, let's write it down, group by trade book, again, of course, percentage P&L greater than 0, and again, we want only the column for the percentage of P&L. And then instead of using the sum, we're going to use the mean, and then we only want the second value. So one more bracket there. Okay, let's see. No, data frame. Let's see time. What was the typo? That's why. So that trade group, and then it should be all correct. No, it isn't. I forgot to close the brackets here, and then the P&L mean, and then of course I have one too many. There you go. Let's see. There you go. That's our average win of 1.74%. Again, we could round as we did before here instead of having all these. Let's do this. Let's round. There you go. So that's our average win, 1.74% for these parameters, which is using a body size of 0.02% and reward to risk ratio of 1. So now that we have all this information, we could repeat the same process for the loss rate and the average loss rate, and actually calculate the expectancy. So if we put here, so we're calculating the expectancy. So, which of course will be that. Let's not copy the rounding at that stage. So it will be that, of course, multiplied by 100 divided by the length. So all the trades on trade book. Sorry, that's trade there, not, yeah, there you go, not the brackets. So that's the percentage, and now we've multiplied by our average win, which you've calculated here. Just copy paste. Let's just break the line there, and then of course we need to sum by sum with our loss probability, which is just 100 minus our winning probability. There. And then, of course, multiply it by our average loss. So, which is this one. But of course, in this case, we don't want the wins. We want the losses. So it's the first column. And then of course, we don't need that round. I will copy by accident. And what else? Yeah, should be. Let's see if I made any typos. It is a long formula. We could have broken this and loaded into variables and not have the entire calculation done inside of the print. Okay. The expectancy is negative, which should not be, because what happened is I've actually okay, so the typo here is that we've multiplied twice the number of trades. As you can see here, we multiply the we divided by the number of trades twice there. So let's remove that. Okay, let's see then. There you go. So that's our expectancy. I hope I don't have any other typos there. seems to be good. Okay, so these are some of the immediate information that you could calculate on this backtesting. Of course, now one of the obvious things you can do is you can play around instead. Let's say instead of using a body size filter of 0.2, let's say if you increase that to double, so 0.4, you run it, what type of data you get there. So you get actually a better expectancy. The profit is more or less the same. You do get less trades. It makes sense because obviously with a bigger body size you're being more selective. And of course you could have played with your reward to risk rate. Let's say we doubled it as well. And you can see what happened here. There's a big improvement in your expectancy, of course, if you're using a bigger reward to risk ratio. Although your total profit for this data set is more or less again the same, 100%. You lost actually around 2% with this change. And of course, one of the obvious immediate things, you could write your code to do an iteration. So you could start, say, with a R of 0.5 and you increment on steps of 0.1 all the way up to, say, an R of 4, whatever you want. And you could do an optimization and see which parameters for this data set works the best. And of course, when I say this strategy is working, I'm saying it's working for this data set, which is hourly candles for SPX. I've run tests of this before. It works for daily data frames and a few other things, but obviously it's not a one fits all solves all. So you should always do your back testing and you should take your own conclusions. This is not a recommendation of any sort. This is just to show you how, using simple Python code, we're looking here at 83 lines of code, very small, and you've back tested your system. And a lot of the stuff that's written here you could reuse. So this you could always reuse to load your SCV, your CSV, your comma separated values data into a data frame. That's always the same. So you could reuse it in any of your back testing. And the logic applied here is often the same. The iteration through the data frame using this is always the same. Of course, the logic then here, it will be different depending on what system you're trying to test. And of course, using these functions to calculate your average win, your probability of win, your expectancy, your sums, that of course would always be the same. So I'm finishing here. This was perhaps slightly longer than I expected. Again, I hope you find this video useful. I hope you find it interesting and motivates you to do more. If you have any questions, feel free to leave them below or send me a direct message. Thank you very much for watching and I hope to see you soon.